In this lesson, we're going to start to put a lot of the ideas that we've been developing so far together. And it's probably going to be the most intense program that we've worked with so far. But if we kind of pick at it slowly, we should be able to figure out exactly what each part of the program is doing. So the plan is to come up with a program that will actually let us just find various prime numbers, starting off with 2 and then working our way through all of the prime numbers on the number line. And so if I ask the program to find the first 7 prime numbers, it'll go and find them in order. The first 7, 2, 3, 5, 7, 11, 13, and 17. And I could just as easily have said, can you find the first 47 prime numbers? And it would go and find the first 47 prime numbers, starting off with prime number 2. How do you actually go through the process of finding this list of prime numbers, 2, 3, 5, 7, and so on? And you kind of have to think that through in your mind before you go and write all of your code. You have to get a good handle on exactly what the process is if you were to do it on paper, and then think about various memory locations that you would need, various variables that you would need to keep track of your task, and then we can actually go and do the code. So kind of thinking about the task in general. If you told me to find the first 7 prime numbers, I would say, okay, well, I'm going to start at 2. That's where prime numbers begin. And I'm just going to work my way through the number line, and I'll either accept or reject the numbers along the way. And if I was to be, for example, at the number 21, I would say, okay, is 21 prime? Well, I'd have to go and check all the numbers from 2 up until just before 21, up until 20, to see whether or not any of those numbers divide into 21. And of course 3 and 7 do, and it's not prime. But a number like 23, you would have to check all the numbers from 2 up to 22 until 1 before the number. And we have to do that every single time for every number to see if it's prime or not. And as soon as we find one number that divides into one of these possible candidates, we have to reject the number and say, no, it's not prime. So if for 23, I would have to check all the numbers from 2 to 22, then checking 2 is a bit interesting. I want to check all the numbers, possible factors, from 2 up until just before 1 below the number, up until, well, that would be 1. So I'm not really going to check any numbers for 2. It doesn't really make any sense. So the values that we check for number 2 are a little bit confusing, but once we kind of get on a roll here, I think you'll see how the game works. So there are no numbers to check for 2, so it's definitely going to be prime. We can kind of give it the green light and say, okay, the very first prime number is 2, and we can increment our little counter of how many we found so far and then print it on the screen. Now we have to find another one. So you move down the number line to number 3 and say, okay, is 3 going to be prime? Well, we have to check all the factors from 2 up until 1 below 3. Well, that would only be the factor 2. And we ask ourselves, is there any way that 2 can divide into 3? It's the only number to check, and the answer is no, it doesn't divide in. It has a remainder. So, okay, green light. It looks like the number 3 is going to be a prime number. So we can go and print it off and increment our little successful count of how many we've found so far. All right, moving down the number line to 4. We have to check and see whether or not 2 and 3 divide into 4. Now, of course, 2 is going to divide into 4. When you try it out, it has a remainder of 0. But you have to go through like a for loop and check and see whether any of these divide in. And so right away, when you check 2 as a possible factor, you realize that it is, and you go, oh, this thing is not prime. Now, there's no harm in checking to see if 3 divides in, as long as you don't go back and say, oh yeah, it's prime because 3 doesn't divide in. We've already seen that 2 divides into 4, so we know for sure that 4 will not be a prime number. So we've got to move on and try another number on the number line, like 5. We have to check all the numbers from 2 up until 1 below the number. So it's a little easier to see the pattern here now. So we're going to go one at a time and see if these things go in. So you try out 2. 2 doesn't go in, so we'll kind of go with a green light for now. It looks like it might be prime so far. Then you try out 3. 3 doesn't go in. Okay, keep the green light. Try out 4. 4 doesn't go in. Well, that was the last one to check, and none of them have failed. So, okay, it looks like 5 is a prime number. In fact, it's the 3rd prime number. So we can increment our little count of how many we found so far and move on to 6. For 6, well, we've got more factors to try out now. We have to try out 2, 3, 4, and 5. Does 2 go in? Oh, yeah, it does. Okay, so it's not prime, and never will be. Does 3 go in? Yeah, it does too. Does 4 go in? No, but we've already decided that 6 is not prime. Does 5 go in? No, but we've already decided that 6 is not prime. Time to move on to 7. For 7, we've got to check 2, 3, 4, 5, and 6. 2 doesn't go in. Hey, this might be prime. 3 doesn't go in. Yeah, looks good. Might be prime. 4 doesn't go in nicely. 5 doesn't go in nicely. All of these have a remainder when you do a division. And 6 doesn't go in. Well, that was all of them. That was all of the ones that we would have to test in a for loop. So we can say that 7 is a prime number. In fact, it's the 4th one. Okay, moving on down the list. For 8, we're going to have to go and try all these factors out, kind of a for loop. I know which ones I'm going to have to do from 2 up until 7. 2 goes in. Okay, not prime, never will be. 3 doesn't go in, but we already know that 2 did. 4 goes in, and so did 2. 5 doesn't go in, but we already found a few factors that did. It's not prime. 6 doesn't go in, 7 doesn't go in. 8 is not a prime number. Let's move on to 9. We've got to check all the numbers from 2 up until 8. 2 doesn't go in. Hey, this looks good. 3 does. Okay, it's not prime. And there's no harm in checking the other ones. The computer's going to do this all very quickly anyways. 5 doesn't go in. 6 doesn't go in. 7 doesn't go in. But we saw that 3 did. 8 doesn't go in. Hey, that one's not prime. Time to move on to 10. Okay, we have to check all the possible factors from 2 to 9. 2 doesn't go in. Not prime. No harm in checking these other ones. We've already seen that 2 does go into 10, so it's not a prime number. Time to move on. So you try out 11. We have to have a for loop to keep track of all these possible factors, 2 through 10. 2 doesn't go in. Hey, this thing might be prime. That little green light means we're going to have a variable to see whether or not it's still possibly prime. 3 doesn't go in. Let's keep that as a green light. 4 doesn't go in. 5 doesn't go in. 6 doesn't go in. 7 doesn't go in. Wow, there's a lot of these to check. More and more to check each time we get to bigger and bigger numbers on the number line. And last one, 10 doesn't go in. We just found another prime number. So we can say, yeah, 11 is our 5th prime number. And then we move on down the road, checking out 12. And you can see it's going to take longer and longer to check these numbers out. Got to check all these factors out. 2 actually is a divisor of 12. Okay, it's not prime. No harm in checking all these other ones. And it looks like some of them do go in and some don't, but we already know that 12 is not going to be a prime number. We have to keep playing this game until we've actually got as many prime numbers as they ask for. And of course it takes longer and longer to check each number. But don't worry, the computer's going to do it pretty quickly. You know, truth be told, for checking out 12, I really don't have to go all the way up to 11. I really only need to go up until the square root of the number. And 11 is actually doing a little bit more computing than we have to. But for now, it just kind of makes sense to lay it out this way. It's very easy to see. And don't worry, watch this. Watch how fast it actually does this. So yeah, I could ask it to do 7 prime numbers, or I could just as easily ask it to do 707 prime numbers. And when I say go, it checks them pretty quickly. And so that's a pretty fast run. So I'm not really too worried about this thing, swamping the computer with calculations. It's going to do it pretty fast. Now, how do we actually lay that out in terms of code? Well, I'm going to have to keep track of how many prime numbers they want to see. I'm going to have to keep track of how many I found. I'm going to have to actually run through the number line and then check each number out and then display them if they're correct. There's a lot of things I'm going to have to keep track of here. So it's time to start thinking about my variables. So I'm going to have a variable called number of primes to find. I'm trying to use variable names that even though they might be long, they're very descriptive for me. That's a lot easier than using the letter N for a variable, because I might not, a week from now, know what the letter N stands for. The number of primes that I found is going to be another variable, how many I found so far. Current number to check, that's where I'm at on the number line as I work my way through the number line looking for primes. The number is prime is going to be a true-false Boolean, so I can see whether or not a number is still possibly prime. And then I have to check a whole bunch of possible factors from 2 up until 1 before the number. And I'm going to try dividing and seeing what the remainder is. Now, the remainder when dividing, that little box there, is not actually a variable for me, but it's just a chance for you to see what the code's going to do. So they type in 7. They say, hey, we need to have 7 primes in the list by the time you're done. Okay, great. Right now I have found none. So at the very beginning of the program, I'm going to have to initialize the number of primes found to 0. And the number to currently start checking at, well, I'm going to start at 2, right? The first possible prime number. Of course, we know it is a prime number. And I'm going to run a loop here to find primes until I found enough. And right now I'm asked for 7, but I found none. I'm going to find one with 2 pretty quickly, but I need to find eventually 7 of them. So I definitely need a while loop. I don't know how many times we're going to have to play this game, looking through numbers on the number line. We could have to go like way down the number line before we find 7 of them. In fact, we have to get to the 17 before we find it. I might not know that right off the start. So I start off trying to check 2, and I assume that it is prime. So I'm going to set that the number is prime Boolean to true, and then I'm going to go through and test factors starting at 2 up until 1 before the number. But think about that for a minute. It's a bit weird. 1 before the number, 1 before 2 would be 1. So there really aren't any numbers to check for prime number 2. I'm going to run a loop generally, though, that goes from 2 up until 1 below the number. Well, here there's none to check. So it is prime, and I can go and increment my count. I don't want to say I found 0. I want to say I found 1. And so I'm going to increment that and then display it on the screen. Okay, great. Found my first prime number, and it was 2. Moving on down the number line. I'm going to update current number to check to 3. Now I have to check possible factors from 2 up until 1 before 3. Well, that's just 2. So I only have to check 2 out. And so I try that out. What happens when I try to divide 3 by 2? Well, I get a remainder of 1. And there's a nice way to find remainders with C++. So if there's a remainder, it doesn't divide nicely. And that was the only possible factor to check. So this number is prime. This number on the number line, 3, is actually prime. It's going to be my second prime. So I'm going to increment this little counter of how many I found, and then I'm going to go and display it on the screen. So I found 2 of them now, and the number that we're just successfully finding is 3. Moving down the road to 4. I don't know, is 4 prime? I'd have to check all the numbers from 2 up until 1 before 4. So that would be the numbers 2 and 3. All right, let's try it out. Does 2 go in? Oh, it has a remainder of 0. It does go in. Okay, we need to update this. The number is prime to false. It's just not a prime number. And you can go and try out 3 to see if it divides in. It doesn't. It has a remainder to it, but we've already decided this number is not prime. Okay, so move on. 4 was no good, so we move to 5. For 5, what numbers do we have to possibly check? Because I think maybe it is prime. So I'm going to go and check possible factors 2, 3, and 4 in a nice little for loop. So I try out possible factor 2. Doesn't divide. It's got a remainder. Okay, that's good news. What about 3? Has a remainder. Okay, good news. What about 4? No, it has a remainder. Hey, that was the last one to check. 5 is prime. So we can increment our count. We found 2 up until now, but now we can say, no, we found 3. And that third prime number is a 5. And we can keep on playing this game. So then we go to 6, right? And you can see how this is going to just go on and on and on. So for 6, you would say, all right, is it prime? I don't know. Check 2, 3, 4, and 5. So here's the code. It's a little intense. It's got some loops of various kinds and some conditions, some ifs in there as well. First thing right off the start, I'm just going to ask the user, how many prime numbers do you want to see? And then I'll store that into a number of primes to find. Then I'm going to set up a little variable that keeps track of where we are on the number line. So current number to check, I'm going to start off at 2. And how many primes have you found so far? Well, I haven't found any yet. And here we go. We're going to go into the loop. I don't know how many times we're going to have to work down the number line. I'm not too sure how far you go to find, let's say, 7 primes. You know, it turns out it's 17 numbers down the number line. So I'm going to use a while loop. And the condition is, well, the number of primes found is less than the number that you need, the number of primes to find. So as long as that condition is true, we're going to have to do this loop in here over and over. So let's look through the loop. First thing I'm going to do is say, hey, the number you've got so far, I think it's prime. So let's just set it to true. And if we find any factors that go in, then we'll reassign that to false. Then we get to this for loop. This is the part that says, all right, check all the numbers from 2 up until 1 before the number to see whether or not those values divide in. So my possible factors, I start off at 2, and I'm going to keep going as long as my possible factors are less than the number to check. And what I'm going to do is I'm going to do a little if in here. If when I try dividing, right, that's what's going on with this percentage sign here. If when I try dividing, if I get a remainder of 0, then I know that it's a perfect factor, and I'll have to unfortunately say that the number is not prime. So I'll set that little flag, the number is prime, to false. And it's okay if I then go and check a number after that. As long as I've set it to false and don't go back, I'll know that this number is not prime if the factor divides in nicely. After I've checked all those possible factors, then that little Boolean variable there, the number is prime, will either be true or false based on whether it is or is not a prime. And so now I have a little condition in here. If that number is prime, then let's do a couple of things. In addition to printing it out, let's increment the number that we found so far. So number of primes found plus plus, that's going to say, yeah, you found one more. And then we'll print off on the screen which one it is that we found and what the value actually is. Then we have to go and say, all right, let's move down the number line to the next number, and we'll try again. And we'll keep playing that looping game until we found enough. So it's a little intense because you've got loops inside loops, you've got conditions inside there as well, but you really want to lay it out in your mind first and go, okay, what would I do on paper in order to accomplish this task? And once you've figured out what you would do on paper, then you want to start thinking about what variables you'd need and then developing your code.